This video is on the distance formula. Distance is the number of units between 2 points on a coordinate plane. It can also be used to find the length of a segment between 2 points. The distance will always be positive. So, distance is the number of units between 2 points on a coordinate plane. It can also be used to find the length of a segment. So if it's asking you to find how long something is, that's the length, that's the distance. The distance will always be positive. You can never have a negative distance. There are two methods to finding distance. You can use the Pythagorean theorem or the distance formula. The distance formula comes from the Pythagorean theorem. So, Pythagorean theorem is used only for right triangles. Now, most people know it as a squared plus b squared is equal to c squared. But what this really means is leg squared plus leg squared is equal to hypotenuse squared. So c is called your hypotenuse. The hypotenuse is the longest side. This is also the side opposite the right angle. So if we were to draw out a right triangle, we'd have a vertical and a horizontal, and then we'd have a side connecting the ending of the vertical and the horizontal. We'd have a right angle here. One of the legs, so the vertical, we could call A, the horizontal we would call B, and the hypotenuse is your longest side. It's the side opposite of the right angle. Opposite means across from. This would be our C. None of these are called A squared, B squared, or C squared. These are just A, B, and C. We square the values to do them, to do the Pythagorean theorem. Now the distance formula comes from the Pythagorean theorem. The distance formula is distance equals the square root of parentheses x sub 2 minus x sub 1 close parentheses squared plus parentheses y sub 2 minus y sub 1 parentheses squared. We're going to take the square root of all of that. This comes from the Pythagorean theorem because this from x sub 2 minus x sub 1 is the change in x values, that horizontal line, change in the x. So that would be our b value. We would square it. Plus, just like a Pythagorean theorem, we want the change in y, which is that vertical distance. So we would have the change in y, which is our a value, squared, just like we have here. But where does the square root come from? Well, if I want to solve for c, that length right there, I would need to do the inverse of a square, which is square rooting, which is where the square root comes from. One thing to remember, just like with slope, the change in y and the change in x, is that the order does not matter in the parentheses, in that change in y and change in x, as long as you're consistent. So if I have x sub 2 first, I need to have y sub 2 first inside of here. I can also do y sub 2 minus y sub 1 squared first. I can do my change in y first. Because we can do this because you get a positive answer when you square those values. So no matter what, I'm going to be adding two positive numbers in here. So if you ever get a negative number out of this, when you square it, you know you've done something wrong. So let's look at a couple of examples of this. We're going to find the distance between the 2 points graphed using the Pythagorean theorem. We're going to use this method. So we're going to create a right triangle out of this. So we want to find the horizontal distance and the vertical distance from these 2 points because we cannot count diagonally. So we want to know this distance. This is our question. This is our question. So our horizontal distance, as we change from over here, would be going from 1 to 7. So that's 1, 2, 3, 4, 5, 6. That is a distance of 6 units. Then we're going to do our vertical distance. From here, at the ending of our horizontal, we're going to count up because that's our vertical change. This is counting 1, 2, 3, 4. This is a distance of 4 units. Now that we have our right triangle, we can use Pythagorean theorem. So we're going to use a squared plus b squared equals c squared. We will round to the nearest hundredth, which is 2 decimal places. So our a value can be either the vertical distance or the horizontal distance. It does not matter. So I'll just use the horizontal distance. So I'll use the 6. So we're going to take our a value as 6, and then we're going to square it. Plus, we're going to take the b value, which is 4, and then we're going to square it. And this will equal to, we want to know what c is, but it will be squared. So we'll have 6 squared, which is 36, plus 4 squared, which is 16, is equal to c squared. 36 plus 16 is 52, is equal to c squared. Now we must simplify this, or we need to finish solving for c, so we're going to take the square root of both sides, because that's the inverse of squaring. So c will equal to the square root of 52. This would be an answer, but it does ask us to round to the nearest hundredth. So we put into our calculator, we'll get c is approximately, because we're rounding it, 7 and 21 hundredths units. Make sure you say that it is in units, because we don't know the actual units. This is our final answer. Now this is a coordinate 1, 2, and the coordinate 7, 6. Question 2 asks us to find the distance between 1, 2 and 7, 6. So the same two coordinates, but using the distance formula. We're going to round the answer to the nearest hundredth. So we should end up with the same answer using the distance formula. So again, distance formula is right here. D equals square root of x sub 2 minus x sub 1, all of that squared, plus y sub 2 minus y sub 1, all of that squared. So to find the distance, we're going to do d equals the square root of. I'm going to do x sub 1 and x sub 2. So I have x sub 2 is 7, so I'm going to have that in parentheses. 7 minus, and then my x sub 1 is 1, parentheses squared, plus parentheses y sub 2, since I use the 7 first, I'm going to use the 6 first, 6 minus our y sub 1 is 2, parentheses squared. Now, the square root and the squares do not get rid of each other because we have a plus sign in here. You have to just keep going with this. So we're going to have the distance is equal to the square root of 7 minus 1 is 6. We're going to square that. Plus, parentheses, 6 minus 2 is 4. Then we're going to square that. So we'll have distance is equal to the square root of 6 squared is 36, plus 4 squared is 16. Then we're going to have distance is equal to the square root of 36 plus 16 is 52. So the distance is equal to the square root of 52, which is what we had earlier. So we know that our values are correct. So our distance is approximately 7 and 21/100 units. Same answer that we had before. This is the only thing we do in this class where the order you subtract doesn't really matter. But why? We're going to have, we know that 6 minus 2 is 4. We know that 2 minus 6 is -4. So when I said that the order doesn't matter, x sub 2 minus x sub 1 is 7 minus 1. Y sub 2 minus y sub 1 is 6 minus 2. But if I had done 6 minus 2, I got 4. If I had done 2 minus 6, I would have gotten -4 in here. But why does that not matter? Because once you square the result, you will get the same positive answer. Because positive 4 squared is equal to a positive 16, which is what we had. And a -4 squared means -4 times -4, which is also equal to a positive 16. That is what that means when the order doesn't matter inside the parentheses. So now I want to show one other way of find the distance between those same two coordinates, but using a mix of Pythagorean theorem and the distance formula. So let's say you cannot graph it, but you want to use the Pythagorean theorem. So we can still use that information to use the distance formula, but not have to memorize the distance formula. So to find that distance, we just need to know the change in y and the change in x, which is very similar to helping us to find the slope. So if we write out our coordinates in a table, we have 1, 2, and 7, 6. So our change in y is adding a positive 4, and our change in x is a positive 6. So that's the part from the Pythagorean theorem, or that's the part for changing of the y and changing of the x in the distance formula. Because distance formula is the change in x and then the change in y. So now we can use these values inside the Pythagorean theorem. A squared plus b squared equals c squared. So now we have the 6 and the 4. We can also plug it into the distance formula. So we have 6 squared plus 4 squared, and then we take the square root of it. So the distance is equal to the square root of 6 squared plus 4 squared. Same numbers. So the distance is equal to the square root of 36 plus 16. Same numbers that we had earlier. So it's still, the distance is equal to the square root of 52. So finding the change in y and the change in x will help us to do the distance formula as well. So we still end up with that the distance is approximately 7 and 21/100 units. Same answer. But this is using a mixture of the distance formula and Pythagorean theorem without having to graph the Pythagorean theorem and without having to memorize the distance formula.